Good morning, everyone. Sorry about my voice. I was talking a little bit too much and too loud last night, so I hope my voice doesn't die on me. My name is Hunter, Ponmocup Hunter. Well, it's not my real name, but that's what my talk is about. Just a little bit about me. This is probably the most boring slide of the presentation, I hope. And just some of my background, education, my current employer. The work I'm going to present is not my day job. It's not something that I get paid for. It's some work I've been doing on my free time, mostly instead of sleeping. So please don't expect some research like from some big company or something. It's just basically a hobby that started from an incident we had at work. So I'm a member and work with several close trusted groups about different things. So if you're interested, get in touch with me in collaboration for certain things. I've given 2 talks about this topic before. The first one at the SANS Summit in July, and the last one just 2 weeks ago. I've had 150 slides in 1 hour on the first talk, and 130 slides in 50 minutes on the last talk. And I thought I'll just use the same talk again 2 weeks later. Well, it turned out differently. I had quite a bit of changes done for this presentation, so there's new stuff coming, and it's a lot of slides, so I will have to go through some of them fairly quickly, but I'll try to spend enough time on the big points so that you actually get the main stuff out of the presentation. So bear with me if I go over some of the slides too quickly. The slides will be available later on, likely after Monday, because there's some stuff in here that's not public yet, and I was asked to hold off the slides till after Monday. So here's a outline. What I'm going to talk about, how we discovered the botnet, what the malware is doing, and how you can detect the malware if it's present in your network. And then I'm going to talk about some technique that I found that I would call anti-sinkholing and how to overcome that. And then there's some references from antivirus vendors in here, some information that I got from their analysis, from their publications, because I'm not a good reverse engineer. I do some basic malware analysis, but not into a very deep level. So I was depending on some antivirus descriptions as well. So why this talk? I want to get people interested in this botnet that I think is largely underestimated. Here is a quote from a guy who would like to remain anonymous. First in February this year, he said he finds Ponmocup almost on every customer engagement. And then he actually went back and looked at data from last year, and he said in about half the engagements, he finds this malware in organizations. So there may be a botnet out there that's not very well known, and I'd like to talk about it. So here's how we discovered the botnet at my company. We're also doing incident response in our company. So it all started with like one antivirus event. I'm not going to tell you the name of the vendor, but it was on March 10th, 2011. We got an AV event, some generic password steal or something generic. And so how many AV events do you see every day? I mean, a few, none, a lot. I don't know, it was just one AV event. Well, we started looking at the proxy logs from this client, and we were able to discover infection path. So the first 5 requests is how the infection happened. You see the red marked request, that was the download of the infector. It was a .com file at that time, but could be exe as well. And there were some requests before that doing a redirection chain. And then about 17 minutes later, you see there was some additional traffic downloading an SWF shockwave, maybe not, file, about 100K, and then some CGI scripts before and after a JPEG download. And that JPEG download, that was a real JPEG file, and that was hosted on a legitimate site. So I'll get into that later, what that was. So looking at those logs, we're able to identify several network indicators, malicious domains where the infector was downloaded, and some domains involved in CNC traffic, and IPs that the domains were hosted on. And we also identified 2 faked user agents from this malware. So different requests were made with different faked user agents. So those are not the standard user agents that we would typically see in our proxy logs. So we actually have different data sources to check. One of them is firewall logs. If some client tries to connect directly to the internet, they would hit the firewall logs and get blocked. And if they're actually proxy aware and using the proxy, they would appear in the proxy logs. So we compared those 2 sources from this client of the AV event, and we saw that it first tried to connect directly to the internet, and about 20 seconds later it would make the same request going through the proxy with authentication. Everything worked, so it was proxy aware. It just tried to connect directly first. That's behavior that we discovered just from analyzing the logs. So then we had some network indicators, and we were using all data sources to find all infected hosts. Looking at the firewall logs, we could search by destination or source IPs, and then correlate that to the proxy logs. And it was an iterative process until we identified all clients who tried to reach out to those same domains and IPs. And we discovered 6 infections in our network that were previously unknown. The first infection was actually 1 year earlier to the date when the AV event happened. So there was like 1 infection, 1 year undiscovered. And then total 6. This is the first, and the second one in March 2010. And the timestamps are actually from the DLL file that we were able to extract or to find in the file system of the clients. So here are all the 6 clients and the infection times from the last 2 infections, which were again both in March 2011, a year later. And we were looking at how to detect persistence of this malware, and we found that it would just use a registry run key, but it was actually using run DLL to start a DLL file that it was dropping, and it would also pass it like a 4-letter key something. So I think without knowing that key, the DLL, you wouldn't be able to get the functionality out of the DLL without giving the parameter. So that's the persistence we found, and we were able to search that, but on a limited scale. But we used that to verify all the infections we found. So we had 29 suspicious hosts who downloaded the infector at one time or another, and we analyzed those, and we had 6 confirmed infections. And on 3 of those, we were actually able to extract the DLL files from the file system. And we also did memory dumps on a few of the systems, but we haven't really done a lot with those memory dumps. But they would still be available to do some analysis. So after identification, we were preparing the remediation. And the strategy was to block all known network indicators at the proxy layer, and to stop CNC communication of all bots at the same time, and then get them cleaned up as soon as possible. But people were still working on those workstations, and we didn't want to just cut off the network completely so people couldn't work on those. So that was the strategy. Here are the domains and IPs that we were able to block on the proxy layer. Those are all the domains and IPs we discovered through the iterative process. So there were more than just looking at the first infected system. Then here are some URL patterns that we used as regular expressions to block on the proxy. So if there were any unknown domains or anything, we would also block it on the URL pattern and also on the user agent level. So we were blocking user agents, URL patterns, domains, IPs. We would just block everything we know at the same time. And funny thing was actually when we blocked the user agent, those clients, they would try to reach out to google.com, like thousands, almost millions of requests a day. And so it was trying to check for connectivity, but since the user agent of the malware was blocked, even that wouldn't work. So let's look at how the infections occur. The infection vector was a series of redirection steps. In our analysis, there was the CGI bin r.cgi pattern was used. Eventually, there was like emerging threat rule created for that. And then a few months later, they started using a URL pattern which looks very similar to a Google redirection. When you click on a Google result, you get a similar request. And then later, last year sometime, they started using a more randomized pattern that there's like 60 different patterns, and we'll get into that in a little bit. And I blogged about some of this stuff on my blog, and not everything. So here's a description from Symantec blog from July 2012. So they analyzed this, and they said it was carefully crafted to prevent exposure. And I would check for different things. For if there was a cookie present, then it wasn't the first request because it sets a cookie. And if there was in the referrer, it would check the referrer for certain things. And also the user agent string, it would check that for different things. So from another researcher, I got a HT access file, a recent one. Thank you, Rick. Is he here? Oh, okay. And I looked at it, and it changed from a previous one that I actually posted on my blog. And it would check for the referrer for certain search engines or social networking platforms or emails. So you need to visit an infected server by clicking a link or doing a search or something. And then it would also check the user agent with a blacklist. So if any known bots, like search engine bots, appear in the user agent string, it would not redirect. and it would check the file type, what file is trying to be accessed, and again the browser user agent, it would check the operating system of that and the cookie, and it would set certain variables based on that. And one of the variable is actually the seconds of the time, which is a value between 0 and 59. And based on that seconds, you will get one of the 60 different redirection patterns. So you don't have just one or two redirection patterns that are known and you can block. There's like 60 different ones. So if anyone wants to write snort rules for those 60 patterns, please go ahead. That'd be nice, if people were actually starting to detect this stuff. So what does it look like if you visit one of those infected web servers? Well, if you start by Googling for something, who has used Google? Nobody? Okay. Well, then you're safe if you don't use them. Well, no, there's other stuff. If you search for certain keywords and you click on a link that goes to an infected web server, you may get an executable served with the search query words, and some people may run that. And hopefully you won't, but some people in your organization may run that, or some people who don't know better. So this is taken from a hacking magazine, and I wasn't aware of this before, but the same malware was also served inside an executable inside a zip file. And I got that from her article, the hacking magazine. If anyone wants that article, I could probably send you the PDF just for that. And here's the screenshot of TCP dump, showing that in the referrer you can see the Google search terms, and you also see those Google search terms appear in the zip file, and the same file name is used for the executable inside the zip file. So the executable is just served in a zip file, and it's harder to block, harder to detect. And here comes the new stuff. Thanks to Martin and Dennis. Hi. Thank you for reaching out to me and pointing out that I was missing the most important part. Because the malware is also served with Java applets, and I know you know all these exploit kits using all these cool, very recent Java exploits, but it's not using exploits, it's just using Java applets, no exploits. It's using a downloaded version with stolen certificates. They were seen valid and not revoked at a certain time, and eventually previously known certificates were expired and revoked, so you may see or find different ones now. And there's also a dropper version with the payload RC4 encrypted inside the jar file. And Dennis wrote a couple blog posts about this, which are very good to read. Here are 2 blog posts, and Martin will release a blog about this on Monday, so he asked me to hold off with the stuff that they shared privately with me. Here are 2 blog posts, and go find them, go read them. They're very good, detailed. The authors actually know better than me. I haven't really done a lot of research on this stuff. Here's the stolen certificate from one of the jar files. He explained how the Java stuff works to download the stuff, and how it's obfuscated and encrypted, and they're using IP addresses from the victim to encode, and it's really complicated, and it probably works very well. So here's just some screenshots of the blog post. You don't have to read all of it, but here's those 2 different jar file versions. On the top is the downloader version, which has a certificate, stolen certificate inside it. And on the bottom is the dropper version, which has an RC4 encoded payload in it. You can see that's about 800 plus K kilobytes. And the downloaded version is actually very small, only a few kilobytes. So now we have additional infection vectors, not just plain executables or zip files with executables. We've got like Java droppers and downloaders as well. And here's one of the stolen certificates that got revoked and expired, and another one. There were probably more certificates in use over time. Here's a screenshot how it might look like if it has been revoked. And here's another screenshot, and Dennis could probably explain better how, in what phase this happened. But the funny thing is the misspelling. Flash is ladding. Yeah, it's ladding. It's not loading. So that's a fun thing. If you can detect that, then yeah. So conclusion about the infection vector delivery. No exploits used. Malware served as executable inside zip files. Java downloaders. There may be some social engineering involved, getting the user to click and open something if it's needed. But the Java downloader version, that may work without any user interaction possibly, depending on your Java version and security settings, I would assume. So now the question is, are you vulnerable to this threat, to this malware? And there's two vulnerabilities that need to be present. First, humans using computer. Who doesn't have this vulnerability? Everybody have people using computers? Okay. Then the second vulnerability is, do you allow your users downloading executable files? If they're able to download the installer for Sidewind, then you may be vulnerable as well. Or if they're able to download executables in a zip file, yeah, you may be vulnerable as well, unless you have a whitelist for all those sites they're able to download. And if they're able to use Java applets from the internet, of course, they're vulnerable as well. Well, hope you have your Java updated, except for it doesn't help here. So sinkholing, that was after the incident when we discovered the infections in our company. I provided the CNC domains to Roman from AbuseCH, and he was actually able to sinkhole 5 of those 7 domains that I know. And so not all of them, just 5 out of 7, keep that in mind. And he's done some statistics over time. He let the sinkhole run for a few weeks, maybe 1 or 2 months, and then he did some blog posts about comparing it to other botnets. And as you can see, it was pretty big. It was like 1.2 million IPs within 24 hours. But almost 650 of those IPs were previously not seen before those 24 hours. And I know from him personally that over several days there were at least 4 million IPs, unique IPs. And I don't know the unique IPs count of all the duration that he was running the sinkhole. I would assume it was even bigger than that. Now I got some statistics from Switzerland, who was all hitting the sinkhole, who all had infections. And I mean, everybody, most companies were on there. There was, of course, home infections from all major ISPs. There was some educational institutes, governments, national, state governments, and companies from all sectors. So it was not very targeted. And so here's some sinkholing statistics. Eventually, the anonymous guy from I got the quote for, he actually reached out to me and sinkholed 4 old expired domains. Eventually they were taken over by Shadow Server, and I got the feeds, the data directly from Shadow Server. and I just took like 1 month worth of data and analyzed that. And there were over 7,000 requests made over those 28 days, and 2,600 unique IPs, 2,600. And that's just from 4 old expired domains. So those infections, they were likely 1-2 years old at least and haven't been cleaned up. So here's a little graph of the number of unique IPs per day over those 4. There were between 150 and 350 unique IPs seen every day. Compare that to the 2,600 unique IPs. You don't see the 2,600 every day. And here's a little statistics of those numbers. Again, the total should be those 2,600, but 85% out of those 2,600 were seen only on 3 days out of the 28. And only 6 IPs were seen every day. So if you just look at a 24-hour period, you only see those 6 that hit every day, and maybe some of the others between 150 and 350. You don't see all the 2,600. Here's some statistics from the fields that I got from the shadow server, POF genre, I guess it's a French word. And I think I haven't verified, but it looks like this is POF fingerprinting, where it actually tries to detect the OS from the IPs hitting the sinkhole. And here's a little statistics of that. So almost 10% are non-Windows systems. Those could be proxy servers or anything else. And from our incident, we used proxy servers. We had 6 infections. We only have 2 external IPs, so that would make a factor 3 for our infections. If you see those 2 IPs on a sinkhole, we have 6 infections, factor 3. So 10% of those could be any number, any multiplicator. So it's really hard to get a close estimate of how big this botnet is from sinkhole statistics. Here's just a few of the IPs. I did some Whois lookups, and I just grabbed a few interesting ones, some banks on there, some governments, and universities, of course. They're all hitting every sinkhole, I guess. But I mean, those infections, they're 1 or 2 years old, or maybe longer. I don't know. Nobody wants to clean them up. So the data is here. If you want to notify them, please clean up your stuff. Yeah, go ahead. So what is the malware? What does it do? From those 3 DLL samples that we were able to extract from the incident, we uploaded it to VirusTotal. Initial detection were like between 8 and 12, which is not that bad. Eventually, over time, they went up into the 20s, 30s, 40 for one. Here's some statistics of what the detection names were from different AV vendors. And actually, the most common one was Wunda, or Wundu, or however you want to pronounce that. That was the most common one, including Microsoft, which has a good detection for that. And Pyramine is another detection that Icarus uses. Actually, for the infector download, that's a good detection name and good alias. Monder, Virtumond. There's other aliases, some variations of this, and then there's some other detections as well. So, this is actually from February last year. That's when I just threw this information on a web page on some server where I did some, not even my blog. It was like, whoever finds it, yeah, maybe it's interesting to you. And I was asking or raising a question: why does every AV company use so different detection names? And I found that like one registry key was common for every AV description. So there was like one registry key which seemed to be common. And I also found that like another registry key, which is random, but for every sandbox analyzing this malware, it's static for every sandbox, even though it's random because you're starting with the same image for every analysis. So if you look for that registry key on certain sandboxes, you find dozens, hundreds, thousands of reports, which I would say is all the same malware. I mean, it has the same functionality. And I found a site from Sophos where you can search for certain indicators like the intohalf.com, that's a known domain for CNC traffic, returning 44 results, searching for an IP address that it connects to 43 results. Now look at the detection names here. No Ubuntu, Ponmocup. Well, here there's one Ponmocup if you search for the software key. And here's an older CNC domain. There's a Ponmocup detection for that. And then other detections. So here are like all the different detection names just by using some of the data I found there. And here's an analysis of it. And the previously known good aliases, Ponmocup, Hermine, Ubuntu, yeah, they're in there, but it's only 10 out of 62, 16%. All the other detection names, like, how do you associate those with this botnet? I mean, there's a CBOT infection detection in there. Well, is CBOT the same malware? No, probably not. So I wanted to have some more data to look at. I got from the guy from VirusShare. He gave me almost 900,000 VT reports that matched any of those 8 detection names on the left. And to get a better sample set, I said, well, I'm looking at those that match 4 or more of those detections, not just one of them, one of the 8. So I was down to like 29,000 reports, VT reports, and I looked at what are the most common detection names on that sample set. And Microsoft actually had the best detection rate for Ubuntu, 98%. So I think Microsoft had some pretty good detections on that. McAfee, same Ubuntu, and then there was like other AV companies using other aliases, which somehow I connect to be the same malware, but they just like to use different names for the same thing. So this site I actually just discovered recently. It's a good site for doing OSINT research, and you can search for domain names, IP addresses, registry keys, basically the same thing as I did on the Sophos site. So here I'm looking for known C2 domains and IPs, and I actually see that Faster Nation domain highlighted at the bottom. This one actually returned almost 1,700 results. 1,700. So here again, just the details, fasternation.net, that's a C2 domain that I'll talk about a little later. And then I wanted to search for registry keys, and it didn't work. So I asked the guys, why doesn't it work? You say you can search for registry key, and they fixed it about 2-3 days ago. Now you can find for registry key like this one, and you get 3,600 results, which is more than double of the previous one. And you actually can see intohalf.com and fasternation.net. Those are the 2 recently used C2 domains during infection of this malware. So what does it do, the malware? I mean, what is it for? And there is some good descriptions from Symantec. There was one guy from Symantec here yesterday. I'm sorry he couldn't attend today. That was after an incident that happened in June last year. I'm not sure if anyone remembers that. Printer virus. A lot of printers printing out garbage and no more paper in the printer. So I'm sure it was fun for certain companies, especially for the ones selling printer paper. So here's just a few a few details of that description. They called it Trojan millisenso for whatever reason, because it didn't have enough other names already. So. There was a lot of encryption involved, and every component encrypted, and the encryption key based on certain system information, and the encryption key encrypted itself, and a lot of stuff trying to hide it on the system. And one interesting fact they described was actually, if you were trying to analyze this malware, it had different techniques of detecting if it's being analyzed, not just VM detection. It was looking at user accounts, at drivers installed, different things. And if it was being analyzed, it would just download adware as a decoy. So not just, stop and do nothing, just download some adware, yeah. So nobody really thinks that's a high threat, right? So at a certain point, the Ueltschi adware was downloaded, and then sanctioned media, some other adware later on. But I don't think that's a real threat. That's a real malware that this would download on a corporate infection or something. That JPEG file that I saw during the incident, that was actually using steganography to hide CNC commands. I mean, who sees botnets doing that regularly? No? Okay. Again, each component of the thread highly encrypted. It actually stores certain components inside the registry. So there's a registry key with a blob in it. Has probably some functionality. And because it uses some system information, every infection is different to the byte level. So yeah, AV vendors need to have some good signatures to detect this stuff. Here's some other description from Microsoft, but that's an older one. Actually, I found a more recent one which has a good detail. Here, the random key under software, which is for the same sandbox, it's the same, but on every other system it would be different. Here again, everything random, and there on the bottom, 50K binary data. That's most likely some malware component that's encrypted and stored in the registry key. Who actually submits registry keys to the AV vendors to analyze? Mostly it just submits executables or DLL files, but I mean, they need that stuff to analyze it. Here's actually a fairly recent description from Microsoft Malware Protection Center, and that has a lot of information in it. I think that's a good place to start looking at what this malware does and what its capabilities are. So, I mean, it could download anything and execute everything. It can spread through the network. That's what it was trying to do when it started printing garbage. It was trying to use an exploit against a printer spooler. And when it didn't work, then it would just print out garbage. Display ads, yeah, that's from the decoy. Stop security services and AV products. Modifies browser behavior, and it sends a lot of information, system information, to the CNC server, to the attacker. And again, a lot of encryption, a lot of anti-analysis stuff. So the installation, Microsoft actually says that it's using 22 different exploits, CVEs. I personally haven't seen anything, and I would like to get in touch with them to see if that's used for delivery or for internal spreading or for whatever. I haven't seen that. So, but it's interesting, 22 different exploits. There's not many exploit kits with that many different ones, I think. Using social engineering, yes. And again, a lot of trying to bypass the firewall, yeah. And here's some of the information that it collects during infection. And some of this is probably sent to the CNC server. or it's trying to find out if it's being analyzed or not. So I mean, there's a lot, everything on your network adapter. I mean, when it's infecting your system, it knows pretty much everything about the system and potentially sends it to the CNC server. From the Hacking 9 article that the malware got analyzed, it pointed out that even the typed URLs in the browser and recently opened documents to registry key would be queried by this malware. So potentially it sees if there are any typed URLs or recent documents, and most analysis systems, they don't have that many typed URLs and recent documents. So another technique potentially used for anti-analysis. And here, again, it states that some of this information gathered from the system is used for anti-analysis or to use to the attacker CNC server. And from the incident, we've seen that additional malware is downloaded like 15-20 minutes later. So there's potentially enough time for an attacker to decide, well, is this, based on the information that he gathers, is this something that I want to send adware to, or is this something that I want to send another Trojan, another malware to for different purpose? It also tries to reset and disable the restore points, and it sends the result of that. So you may not be able to restore the system to an older state. So I mentioned there's like one registry key that I've seen in most analysis and doing analysis myself. So I created an IOC for that and published it. It's very simple. It's just looking for a registry key. There's other ways to do that. If you have the means to do that, why not look for a registry key on all your endpoints? You may find some infections that way. And I tested it on a VM that I infected, and would see if it works. And yeah, it's easy enough to detect a registry key using IOCs and the free Mandiant tools. So that stuff's public, it's available. Now here are the IP address ranges that I know of for the first step, redirection. So that's when you hit the Google search and you get redirected to, or after you visit the infected web server, you get redirected to the second stage. And that's like all the IP ranges that I've seen over the past 1 or 2 years. So we blocked that in our company at the proxy. And whenever I see a hit to one of those blocked URLs, IP addresses, I look at the URL and I find like new infected web server, and I add them to my list to watch. So that's how I discover new infected web servers, which is very small amount. Here again, those two domain names. If you see any DNS resolutions of those two, you may want to start investigate, because that's a good sign that infection is occurring, because the malware first resolves those one of those two. Actually, the faster nation is the one most recently used. I don't know any more recent one. And if you can look for DNS requests, look for connections to those IP addresses, or look for the registry key. Over time, I developed a little script, a little tool, Ponmocup Finder. I blogged about it. You can read all about it on my blog. Basically, I feed it a list of domains that I know or suspect were infected, the web servers, checking for the htaccess file, and the script is very simple. It just does like one wget request with referrer and a special user agent, and it looks what is the result I get back. Do I get a redirection request back? And is it redirecting, and the domain passed as URL parameter? So that's how I detect those infected web servers with htaccess, the malicious htaccess. It's a very simple thing, and I wish search engines could do that and crawl the whole internet and find infected web servers that way. They don't find it because they use a bot user agent. They don't find the redirections. Maybe we make one request per domain, and you might actually find this stuff using search engines, and they could alert the user using certain browsers. So the stuff is very easy, the scripts, nothing really great. I started out with just a few domains. What was it? February this year. And eventually there's like a little peak in there, and I'll tell you later what that was. And now I'm monitoring maybe 1,000 domains every week, one or two more that I find. And currently there's still almost 600 infected web servers redirecting to this malware. If you want to do notifications, tell them, clean up. Here's the infection ratio of the ones that I monitor. It's between 50–70%, going slowly down. And here's actually why the little peak. I got a list of infected web servers from I'm not going to pronounce his Twitter handle, but you can read it. So someone gave me a list of domains that they found through their log analysis. I'm just feeding it to my stuff, and the data's there. Now, I've analyzed how many days I've seen each domain infected. There's domains in there infected for hundreds of days, and there's domains in there that are infected only between 1 and 6 days. There's a lot of .ch domains in there, and the reason, because I know the people from SwitchCert, I collaborate with them, they use my feed. It's publicly available, it's free. I mean, everybody can download these files. They monitor that. If they find a new CH domain, they do notification to the owner. They have 24 hours to clean up. After 24 hours, their domain is suspended for 5 days. And after that, they have to do additional means. But I mean, they're very aggressive cleaning up the .ch domains, and they're doing a good job. And I hope more people, more registrars would do that. So let's get into the anti-sinkholing technique. This is an analysis that I did in October last year. It's also public available with PCAP and screenshots and everything I did. It's very basic, I guess, to most real reversers and malware analysts. But it's showing also the infection pattern. And you see the into half. That was last year, so that's when into half was still used. DNS request returns one IP, 64 something. And then there's a C2 connection to another IP, not the one resolved by the domain. So suspect that there's some function connecting one IP to the other. I didn't know what the function was, but eventually I found out. So here, that into half domain, some PDNS data for that, started being used in July last year, and it changed IP addresses in January. So, and then the IP addresses that the malware connects to changed at the same time. So that was kind of an indicator that it was really a function. And here's the latest in use, fasternation.net. Again, DNS request to this would mean it's an infection occurred. So, and there's VirusTotal reports where you can find this stuff, the domains and the IPs it connects to. So I really wanted to find out what the function was between those two IPs, and what better way than to ask Twitter, or your very intelligent followers that I have. I'm very thankful for. And so I just sent out a tweet and said, who knows the function if IP is blah, 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 and some keywords and reference. And I got some feedback, and just a short time later, I got Short answering me with, it could be as easy as an XOR with a key. Well, let's try that. So I tried it with all known 3 indicators that I had, and it worked because I had like one domain resolving the 2 IPs and 2 other IPs, and it was the same XOR key. And then I don't have any other means to verify it for the latest use, but it was a different XOR key. But the IP address for fastconation hasn't changed, so I'm not able to verify. But it seems like every new domain used for a DNS uses a different XOR key. But knowing that XOR key, you would be able to actually sinkhole the C2 traffic. Without that, you cannot sinkhole it. You can sinkhole the domain and see DNS requests coming from somewhere, but you won't actually see the HTTP traffic to your sinkhole. So who else is tracking this botnet? Earlier this year, I looked and found some Kindsight reports from last year. And the first quarter, they had it at number 11 for 20 home network infections, and number 4 of high-level threats, top high-level threats. So they had it on the radar first quarter, and then second quarter it was less ranked, and then it fell down. Fourth quarter it disappeared, so good, botnet's gone, right? Yeah, that would be nice. That's the most recent Microsoft security intelligence report. I hope you people actually read that stuff. And there is a Wundu, which is the best detection, the best alias for this malware from Microsoft, being on rank 14, which is fairly low, but I'm not sure how accurate that ranking is actually. And so here's some descriptions from the SIER report. You can look that up. Just a few weeks ago, ThreatStop blogged about, now they're blocking Ponmocup as well, and they're referencing my blog actually. And they classified it as a considered less harmful, as it seems to use to be, only for adware, click fraud. Yeah, that's all the decoy stuff you get. But there's no reason to assume that this will remain the case. Well, at least they have the thought that it could be used or in the future for something else. And I think the real purpose is not to serve adware of this malware and botnet. So, okay. How to stop the malware from spreading, or how to take down the botnet. There's some ideas that I touched on already. Anti-sinkholing, that's solved. You know, if it's an XOR key, could change for every new domain. Using the OSINT from a total hash, I'm able to monitor if new domains are being used. So just search for that registry key on total hash, and it shows the most recently used C2 domains for samples that, of course, were submitted and are known. So, but that's a good way to monitor for new domains being used. And there's a lot of unknowns about this botnet. I only know like one domain being used during infection. I don't know anything else about the current C2 domains, IPs, URLs being in use. So I have no idea how to sinkhole it and see how big it is at this point. None. So I guess an idea about this would be to find a company that you have high confidence that has this malware in it and has the capability to do the same analysis, investigation that we did. And through that, going to an infected company, and you would be able to analyze the logs, maybe get some images from compromised systems, and find out what it's actually doing inside corporations. Because I've heard from someone that there's been an incident with such a bot infection, downloading some other malware which is typically used for espionage. So this could be something like Mariposa was, doing espionage and just serving adware to the home users and people trying to analyze it. I'm just speculating here. So, but there's a registry key that you could look for, and I mean Microsoft, they may have the means to put that in their tool that people use, or in their AV that companies use, and just look for that registry key. That may be the best detection. I don't know. And then the search engines, the crawlers, use like one request per domain per server, detect this stuff like my very simple script does, like find this infected web servers, stop them from spreading it. And I have a lot of more ideas, and I put a lot of free time, I put a lot of missing sleep in here in this work, and I would like to get other people involved, tracking this stuff, stopping it, analyzing it, whatever. I have some ideas that I would like to share. I would like to collaborate. I just don't have many more sleep hours I want to miss and spend on this stuff. So I'm reaching out to people. Get involved. I started a Google group for this, a working group. I'm not sure if this is the best platform or the platform that will stay for a long time, but I'm already collaborating with a few guys on here, and maybe there's a better platform to do this. Maybe we need to get some big companies involved, like Google or Microsoft, who would actually have means in detecting this stuff. So I would like to thank everybody who helped me in one way or the other with this research, with this presentation, especially the two guys in the working group who showed me there's other infection vectors. And there were a lot of slides, and I hope I didn't miss any of the big points that I wanted to make. Maybe I forgot some, and I'm sure there's a lot of questions, and I'm not sure if I have enough time to answer all of them. But if we do have time for questions now. Thank you.
1, 2, okay. 2 short questions, if.
Hi Tom, this is Sad. I was wondering if there is anything behind click fraud in adware of such a complicated malware. They go to the extent of encrypting everything, etc. By the way, I would like to congratulate you for this excellent presentation, the excellent work you put in there. So yeah, I was wondering if there is anything behind that, because it seems like too cheap to do all this stuff just for click fraud in adware.
Yes, exactly. That's my point, because everybody, I mean, the Hacking 9 article, that was about the adware served and how it could potentially steal some information. I don't think that's the real malware that's being served to like corporations, or, I mean, the information they get during infection, they know if you're in a domain, if it's a real user inside a corporation, they can send different malware to some high value target, or just kind of let it sleep there for a year. We've seen it in our network. We found it active for a year. We didn't find it through some activity it was doing. We found it through one 180 event. So it could just have like sleeper infections in corporations and trying to sell them off to whoever wants access to that corporation, and then download some espionage malware. I mean, it could do potentially anything with the functionality that you find. So yeah, the real motivation behind this is it's very stealthy. It's trying to hide very well, and the real motivation, who the attackers are, attributions, like, I don't know. I can't do it all myself.
Last question.
Dennis? Yeah. Was I clear about the whole Ponmocup? I didn't actually mention the name, but Ponmocup is what they came up with the name for the kit. There's a kit basically after you get redirected from infected servers. There's a whole kit that looks for what IE version you're using, and it serves like either an executable or zip file or Java downloader, Java dropper. So the whole thing, that's not my work. Someone else knows that better.
Thank you.
Thank you.